So this is a hot topic, so we will only be on for 30 minutes, and the clock has already started. So for those of you that are new to PROergonomics, we are an ergonomics health and safety consulting and training services, and we have been helping clients all across Ontario and elsewhere actually help save money and reduce injuries and overall build their ergonomics program to a place that has a really proactive approach to it. That's kind of our tagline: productive, proactive, and that's where we like to be, as well as professional, of course. So without further ado, we're going to kind of jump into it. I always find my first slides are a little bit slow, so give me just a second. There we go. So yes, so today, I'm not sure who was with me a few months ago, but I was the one, apparently I do temperature. I didn't know this, but I do. So I did hot a couple months ago, and now we're doing cold. So we are right now, at least where we are, not experiencing a ton of cold. I think we're sitting at a balmy 9 degrees today. But we know that that could go very cold within a day or two at any given time being here in Canada. So we are looking at what is that ergonomic or MSD risk or component when it comes to cold. So for the agenda today, we're going to be talking just a little bit on the legislation on cold. What's the physiology of cold? How does our body react? And how is that affecting our work? How are we able to perform or not perform given, colder temperatures? And some of you may be surprised at when cold kind of starts getting defined. And then we'll be moving into our controls, looking into what some of our administrative, our engineering, and of course our PPE. So without further ado, let's jump on in. So the question is, what is too cold? And often when I've worked with facilities that are indoors, temperature becomes a very personal, almost political subject matter for those of us that are in health and safety. We get a lot of calls in the office of people, complaining of drafts and cold. And at what point in time are we required to kind of look at that as being a systemic problem? When we are seeing temperatures continuously at a minimum of 18 degrees, then that's when we start knowing that we may have a problem with cold and that the body may not be performing as well as it could in maybe a slightly warmer climate. Now that is for your indoor offices, your hospitals, your schoolrooms, your plant floors, those types of things. 18 degrees is kind of the Ministry of Labor government standard that we start looking at. However, for those exceptions, those areas in our food industry or medical where there's maybe freezers and fridges and work is involved in there, or we have outdoor field worker environments, there is actually no minimum or maximum working temperature. So that is something to kind of look at. I always get this acronym wrong. I should have put it on the screen. The ACGIV, those people, the hygienists, they have given us some guidelines. So at -7 degrees, if that's the temperatures we're looking at, we should be providing warming shelters. And at -12, there should be buddy systems, appropriate clothing, paced work, and reduction of static work. So just some kind of things to kind of look at as to, depending on where you are, what you do, and what your facility organization kind of workload looks like. If cold is a factor, then those are some of the temperatures that maybe should act as either red flags or even yellow flags for you. So when we're talking about what can go wrong when cold is in place, often we talk about temperature as being one of the main MSD risk factors. However, when we talk about heat, from a muscular standpoint, our muscles actually like heat. They're pliable, they're warm, they're stretchy, they have the maximum amount of blood flow going through them, so nutrients and energies are rich, and the capacity to do work is high. However, when we start getting into cold, we know that some of the muscular systems don't perform as well. But there are other things that go on. We have all this whole cold stress category that comes into play. So we can have more minor issues where we're starting to have redness, frostbite, frost nip, those type of things, we may start seeing tissue damage if that frostbite starts to do more permanent damage. We have hypothermia, that's definitely a more critical concern, shall we say, where we have increased numbness, slurred speech. Obviously, it could be end up in death, depending on how long or how, I guess, harsh, I guess, the hypothermia is, for lack of a better word. And then we have the MSDs that kind of creep into there as well. We have that increased muscle tension, the decreased blood flow, that's going to just act as a catalyst to tissue breakdown and increase our internal forces in the body. We also, specifically, we have Raynaud syndrome, which is classified under our MSDs, and we'll be talking about that kind of hit and miss as we go through the slides. So as kind of a note and something to think about, and something we may touch on a couple of times throughout the next 30 minutes, is that nose, ears, fingers, and toes usually are the most likely to be affected because they are furthest from our core. And when it comes to looking at, you know, what the body's priority is to keep safe, keep warm, it's definitely going to focus on the core. So when we think about manual work and what we need to do, mobility, toes, feet, that's a big one. Hands, we don't do much without our hands. So nose and ears, maybe not come into specifics of the day in, day out, but fingers and toes are definitely one of those areas where if we're suffering from common injuries from cold, they're going to impede our workflow and potentially our return to work or our accommodation strategies as well. So some points of interest are I feel like this slide is maybe a little bit far ahead. So I'm going to actually skip back. Sorry about that. So when we're looking at the physiology of cold, we actually have the body's aim, the goal is to try and keep our core temperature at 37 degrees. When we are in a cold situation, what our body typically does is it shuts down the smaller blood vessels to our extremities, to our skin, so that it can basically redivert blood flow. It's like blocking up the vents in your house. You block up one vent, you're going to get a stronger flow in another area of your home. So this is working under the same concept, and that way, you know, we can live without a hand or an arm or a toe, but we can't live without the vital organs that are in our core. So we'll often see that this physiology starts to kind of click in, and it's shocking actually when it does start to click in. We'll talk about that in a second. So we then will start to see shivering start to keep the body warm. If you think about the mechanics of shivering, you're tight. There's like a high frequency vibration or contraction happening in the muscles. So when we're trying to do physical muscular work on top of that, there's an added stress and added strain to the musculature that we're looking at. So those points of notice or points of interest is that whole vasoconstricting process that our body does actually doesn't occur in the head or neck. So, which makes sense, you know, we want to make sure that no restriction of blood flow is happening near the brain. So we don't have that vasorestricting processing happening, which means that, and we all have heard the statistics, but this is why 50% of our body heat can be lost through those areas if they're not covered or protected. Also, when we're thinking about manual work and things that we have to do for our jobs, our skin is highly sensitive. So when we're looking at some of the cold stress issues and injuries that may come into play, our temperature our skin temperature can actually drop to 0 within seconds when in contact with a very cold item. So it doesn't have much insulation ability to maintain its body temperature for any long duration or time. So we can often see if we have contact with really cold items, then without protection, we can expect to see some of these stresses from cold stress because we have no ability to combat those. Okay, so moving forwards, we kind of have this effects to work. So we've seen under normal conditions, we have that really large opening in the artery system, kind of really pumping blood through. It's pumping through to all our extremities, to all our skin surfaces, and we're kind of getting the optimal situation as far as what our body needs to do physical work or labor. When we look to the other side where we can see cold has been introduced, we can see how small that opening in the blood vessels is and how much restriction is kind of happening. So we can't do much without blood flow. Like, our ability to do work, to function, definitely becomes much lower when we have a decreased blood flow to that system. So as that blood flow is being pushed into the core for heat and thermal control, we do have a payoff that's not necessarily in a positive sense to those extremities and muscular systems that we're trying to use on a daily basis. So it leads to lower work efficiencies, which may then come into our higher accidents rates. We start to see impairments to our mental processes and our alertness, as well as we mentioned before, we have a reduction in strength and an increase in joint stiffness. We can also start to see, because we have such a smaller blood vessel opening happening, our blood pressure is going to increase. So that's called cold-induced hypertensive response, or CAHR, and we definitely can start seeing some negative effects to that, as well as if our employees are currently suffering from hypertension, then this could be an added risk factor for them to kind of work through. So we definitely see an ability to do less work. So when we are providing workers with cold environments, regardless of whether it's, as I said, indoors, outdoors, or those exceptional indoor situations like our freezers, our fridges, so on and so forth, we need to have an understanding that we're not putting our strongest foot forward as far as the human capacity goes. We are starting to restrict what our employees are able to do, what they're able to output, and what our expectations should be. So this is kind of just a bit of a flow chart. So you can see on the left, we have a cold environment. We maybe have added clothing to try and help insulate against that. But depending on the clothing, you may not have the right clothing. So we may see an increase or decrease in body temperature. Now, if you have motion, that's not so bad, because that's also going to increase your skin temperature. So that's a positive. We then get into the thermal regulation, the physiological strain, what's going to happen with our performance, again, moving on to our task performance and our overall health. And as you can see, depending on what the tasks are, it's going to potentially aid and cycle back into your thermal regulation. But we'll talk about what that looks like. Going out and, doing very physically heavy work may not actually be aiding your thermal regulation processes. So, for instance, this is kind of a bit when we're talking about hands. I mean, at the end of the day, we have yet to figure out how to do most of our daily living activities or work activities with our feet. So our hands definitely become a focal point when it revolves around injury and work. So you can see on the right, we have kind of the scale of what temperatures we're looking at, and you may be somewhat surprised at some of the temperatures that we're seeing here. These are quite high. So for hands, feet, our ambient temperature at a temperature of 11 degrees Celsius. So we're not even talking below zero at this point. At 11 degrees Celsius, we will see up to a half of a reduction in what the overall performance we should expect from those body parts, which is quite astounding considering, if we, for instance, maybe it's, even if it's assembly line, but the assembly line is next to a shipping bay and it's now seasonal temperatures, the shipping bay doors are open. If we're seeing productivity come through in the summer, spring, early fall, we may start to see a drop in that or an increase in errors come the winter or the later fall months or early spring. Due to this, we're starting to see temperatures dip and drop below that or towards that 11 degrees, and we're physically not able to have the same dexterity, the same tactile sensitivity, and if that's the case, if we're dealing with sharp objects, we may lead to more cuts and and just overall MSDs, I guess. So then we kind of get into kind of identifying our controls. And it's interesting because I think most people think, you know, oh, well, we, you know, dress appropriately is the word we hear the most. So if you're working on a line, if you're working in an office, if you have to go into a fridge, then there's clothing that can be worn that's appropriate for that. And so that does seem to be a go-to for a lot of our clients, a lot just industries in general that have those environments at hand, and even those that maybe don't have it day to day. I mean, in working in some of the college systems that I've been in the past, you know, the heating system doesn't necessarily always work as well as you want to in some of the buildings, and or you have employees that like a cooler temperature and are messing with the thermostat. So we may start to see those temperatures start to dip to those 18, lower temperatures, 11 degrees, depending on the situation. And so clothing, although, yes, should be a part of your control strategy, it may not be the bulk of where we need to spend our time. So thus going into the clothing may not be the answer. So, sorry, here we go. Sorry about that. So we know from research, statistical data, that gloves in its own right can decrease our tactile sensitivity, can decrease our dexterity, which means we typically will exert more force, more grip strength when we perform tasks when we're wearing gloves. So that although, yes, it is combating the risk factor of cold, as an insulator, it may not be combating the risk factor of some of our MSDs, where we're trying to decrease forces. If you've been following us for a while, I've often said, you know, if most of the time we talk about our MSD hazards in terms of that they are kind of equally weighted, which isn't necessarily the case. In fact, most times it's not the case, but the nuance between how you would weight them may be quite minor in fluctuation until it comes to force. I feel like force on its own, because force activates not just as an MSD, but it also could act in a... Oh, I'm so sorry. 1 second. Today just doesn't seem to be my day. I apologize for that. So we have the fact that that increased force is definitely something that we always want to try and minimize in our work environment. But when we add gloves to combat the risk factor of cold, we are knowingly increasing potentially the force component. So we have some of the fact that if our work is outdoors and we're not able to control through the thermostat, through potential clothing to the highest degree, then we know we're going to have that physiological response that we talked about, whereby we're not just going to be potentially experiencing the MSD hazards, but we're also going to be experiencing some of the those cold stress, the skin trauma, the tissue trauma, the hypothermia, but also those mental kind of sluggishness that we may end up having other health and safety issues. We also have the issue that if our clothing, if our protective clothing for against cold is not appropriately chosen to the physical tasks that our employees are doing, then we could cause and create a situation where our employees are sweating. And for those of us that have, you know, have those jobs, or maybe even just personal activities that we like to do outside in the cold, sweating, cold temperatures are not going to meet or align nicely, and it's going to actually decrease our thermal regulation abilities and not increase it, and we may end up having further issues and lead closer to that hypothermia status rather than kind of hovering in some of the less extreme injuries that can happen when cold is present. Now I'm not having my computer respond to me. If we are trying to bundle up, then these are some of the considerations that you want to take into thought. Your fine manual dexterity will need a thinner material. So depending on what that is, if you're able to get the same, I guess, insulation factors with a thinner material, that's great. Typically, we want to see fine dexterity work happening in normal temperatures. Light work, you know, we can probably start to see hand protection coming in at 4 degrees. Moderate work, -7, and anything below -17, we should even not be thinking gloves. We should be thinking mittens, because those digits need to be close together in order to help generate their own heat as well. When we're looking at footwear, again, we need to understand, what are we looking at? Are we indoors in a fridge or cold area? Then felt-lined, rubber-bottomed, leather-top boots, removable insoles in case our feet sweat so they can dry out and they can breathe. But if we have wet areas, then we need to have that waterproofing. We cannot be having that dampness come into play, because, again, that drops our body temperature significantly quicker than if we don't. And again, when we get into apparel, and we talked about this in our heat discussion, and that is, we have kind of a very firm belief that that cotton is our friend when it comes to appropriate clothing. It's natural fibers, it's lightweight. However, cotton is not the quickest to dry out, and it actually will absorb quite a bit of moisture. So same within the heat situation, where we're constantly looking at airflow to help regulate our body temperatures. And if a cotton shirt was to get sweaty, it's likely to cling and stop that airflow, therefore stop the thermal regulation. Also, similarly happens with the cold. So again, cotton will get wet due to sweat, due to water conditions in our work tasks or work environment, and it does not dry out quickly. So that cold, that wet, that damp is on our skin, further reducing our body temperature. So ideally, we like to see quick dry materials close to the body. And then as you work your way out, you want to see more waterproofing. So they don't necessarily have to be, you know, the thickest layer on the outside. You kind of want to have thin layers, insulating layers, and then waterproofing layers. And that's kind of what you should be looking for as a strategy if you have field workers or people outside where we're getting into the minus, below zero working temperatures. So as far as administrative controls, this is fairly conclusive across the lines. No matter what research you look at, what health associations you're kind of perusing, this is the strategy when it comes to dealing with cold that we typically will see. So in areas of cold, there definitely needs to be some kind of supervision system, whether it be a supervisor, whether it be a buddy system, but someone trying to monitor the work to ensure that, you know, sluggishness, hindering of mental capacity or processing is not occurring. And what should come with that is training. We can't ask people to monitor what we don't know. So train them on the symptoms and the effects of cold stress to make sure that that monitoring system and that surveillance is actually going to be impactful and do what you want it to do, which is part of a thing that I see sometimes they don't align quite well, or they don't train it regularly enough for it to come into play, specifically if your exposure to cold is seasonal. Then this training should be a little bit more robust and a little bit more aligned with the seasonal dips that we'll see. We need to adjust the pace of work. So that means decreasing our stationary work. We know standing still in cold temperatures is not going to be good for us. So if you consider our food industries, where often, you know, meat processing, a lot of the cutting is you are statically standing, potentially on a conveyor, and you're doing cutting. So the pace of work, we want to try and minimize the stationary or static work, but also we need to coordinate and structure or schedule our physically demanding work, because anything that causes us to potentially break a sweat is going to be working against us. So we might do that through job rotation, and we might do that through, area location, where they rotate through different areas that are going to be higher in temperature, whether that be vehicles outside, if they're field workers, or different plant areas. If you don't have those areas available to you, then the recommendation is that they try to be provided, and that we have increased break frequencies depending on the hour or the amount of work or the temperature that we're looking at. The one thing that we're not talking about in this, and if you have field workers, it is something you may want to look at. I believe the next slide does kind of touch on it a touch, and that is wind. Wind chill is not something we're getting into today, but it is something that can be a bit of a game changer when it comes to trying to control for cold, because obviously you may be looking at a temperature or a thermostat that's giving you -7, but we all know that it could feel like -17. So that can be a bit of a game changer, and your strategies may need to change according to wind chill and how that's going to affect your employees. So this is kind of what I was talking about. It does touch a little bit on your wind chill, but it kind of tells you what your break periods should look like and what your maximum work period should look like based on at least your wind velocity. So it's not, if that's a warm wind, it may change a little bit as well, but kind of assuming that we have that colder temperatures, we're having wind chill occur, then we need to be looking at a strategy kind of something like this. And then we have our engineering controls. So our engineering controls is usually where we like to hang out the most. However, for a lot of our industries, if you're talking fridges, if you're talking outdoors, engineering controls become a little bit more challenging. So whenever possible, providing an area with a radiating heating source to allow people or your employees to warm up, to heat up. If there is work happening outside and that wind velocity is a potential risk factor, then looking at providing some kind of shield or shelter, something that's basically going to allow them to block that wind factor while they're performing the tasks that they're trying to, whether that be, using their vehicle and parking specifically so that that's acting as a barrier, whether we're providing them with an actual physical barrier that they could set up around their work area. Fishing tents type thing, if it's kind of a contained workspace, would be something that you could use to minimize some of that cold as well as that wind chill. If we know we have tool use happening, then looking at our tool handles, looking at the contact where our hands are, yes, we may be insulating at the hand with a glove or a mitt, but we could also be insulating the handle of the equipment. Anytime we're getting into, harder plastics or steel or metal, we're going to have much, much colder hand grip status, which is going to combat and kind of counteract what you've done with your personal protective equipment, your thermal regulating equipment. So looking at even one of my favorites for any kind of tooling or handles is tennis grip. It's dampening against vibration, it's dampening against heat, it has an absorption quality, so if it was to get wet, it's not necessarily creating a slick surface, but it will dry out because it's intended for sport. So all of these things have kind of already been considered. So, looks like my time is up. Couple more slides and we'll be done. In cold facilities, looking at what your airspeed, our airspeed should not be exceeding 1 meter per second. So in your fridges, your refrigerators, any other areas that you have where you're working at reduced temperatures, making sure that those fans are not increasing, picking up any kind of almost internal or indoor wind chill factor or wind velocity factor. We talked slightly, actually, if we didn't, I said I was going to, about Raynaud's disease, which again is another MSD that is typically a result of vibration. But when we're looking at vibration at cold, your risk for Raynaud's is that much more increased. When I spent the beginning of my career, I was working as an ergonomist in the mining industry, and we would see higher rates of Raynaud's there because we would have damp, cold work environments, high vibration tooling, and that wasn't a great match. So, and provide heating sources. So we could use potentially these body warmers, these heat hands that we can put into our clothing, put against our body as a wearable source of heat. But vehicle heaters, space heaters, all could be, I know that's kind of a bad word in the admin kind of sector or industry, but they may be something that you need to look at if your environment is suffering with temperatures that are going to make it challenging for your employees to work and or work without injury. So that is it. Only 30 seconds over, so not too bad. Our next month's webinar will be on ergonomic products. And are they really ergonomic, which is a great topic. Can go out anywhere, and the word ergonomic is splashed quite liberally around as a marketing strategy. And when you look at the tooling or the design of the workstation or whatever it is you're looking at buying, the ergonomics really aren't there for some products, not for all. So becoming that kind of informed consumer can definitely be happy not getting caught up in that ergonomic branding. If you have any questions, please let me know. I see that we may have a couple. One is just, can we get a copy of the presentation? And absolutely, we will be sending a link. So all of our webinars with their interruptions, I apologize because I'm sick. I'm actually working from home today. They get recorded, so you can hear my dog later at a later date. But they will be posted and sent out to you, and you can reference them as many times as you like, or share them if you so choose. And I don't see any other questions, so at this time I will sign off, and I hope you have a great day, and we'll see you next month. Take care.